We are the Madagascar mission, which stands for Martian Autonomous Deployment for Advanced Geological Assessment, Subsurface Cave Access, and Reconnaissance. Our main mission statement and goal is to assess the viability of Martian lava tubes for sustained human habitation. It has been hypothesized that Martian lava tubes could be a candidate for both places of scientific value and also a location for human habitation, as it could potentially block from harmful radiation and weather events on the surface of Mars. To investigate these claims, we will be deploying a novel tethered exploration vehicle to descend into a Martian skylight lava tube and collect spatial mapping, radiation dosimetry, and atmospheric condition data. This graphic is our concept of operations. As you can see, we will launch on a Falcon Heavy from Cape Canaveral and then eventually land on Mars using the Sky Crane infrastructure. We will then deploy our main rover, Julian, which will drive to the Martian lava tunnel access point. It will then deploy MORT, the scientific rover, via a novel tethered system in order for it to be able to collect data on the way down and also transmit it back to Julian.
Here are the different phases for our Julian rover. After landing performing the health checkouts, it will begin a traverse mode where it will alternate between a move phase and a rest and calm phase. During the move phase, it will be driving for 90-minute periods with up to 200 meters per day of travel time. This will also be a semi-autonomous mode. During the rest and comms phase, it will use its RTG to provide warmth to instrumentation overnight, battery recharge, and communications back to Earth. Once it reaches the lava tunnel entrance, it will enter its base station mode, where it will alternate between a battery discharge mode to provide power to MORT along with communications back to Earth with telemetry data. Then once it is depleted its batteries, it will enter a RTG mode, where it can begin charging its own batteries along with MORT's batteries. These are the MORT mission phases. The first phase is the descent phase, in which it will travel in 10-meter segments down the cave wall. In between these 10-meter segments, it will begin its data collection by taking data with its LiDAR sensors and HAZCAM sensor along the wall. Once at the bottom, it will begin an exploration phase, where it can explore up to 1,000 meters into the cave. During this phase, it will alternate between a data transfer and move phase for the traversing, along with battery charging and communication.
Here is the preliminary look at the trajectory. The plan is to launch from Kennedy Space Center on April 25th, 2033. We'll be using a Falcon Heavy, which will put us at a parking orbit around Earth at an altitude of 400 kilometers. The next phase of the trajectory will involve a boost towards Mars using the launch vehicle, and that'll happen on April 28th, 2033. Cruise is estimated to take around 270 days, and this will put us into a Mars interface orbit on January 25th, 2034. So here's a look at the sensor suite aboard MORT. The primary goal, as mentioned before, is to map the interior of the caves and also obtain atmospheric data and radiation inside of these Martian lava tunnels. We'll accomplish that using a combination of LiDAR and HAZCAMs to map the inside of the cave, and we'll use the high energy neutron detector, or HEND, to map the radiation levels, and the environmental study suite will give us the atmospheric data, and this is capable of measuring pressure, temperature, and humidity.
Nice rendering of the combined Julian and MORT vehicle. So at the front is where MORT is stored, and then Julian is the main rover that will deploy MORT via its tether system. Top-down view of Julian and how we've laid out our different subsystems. So of course we have our RTG at the back. Between the RTG and the MORT deployment system at the front, we have our tether spool, which houses 1 kilometer of tether. We also have our batteries and our TCF's coolant pump. And here from the side, we have our camera to help it navigate. We have our comms antenna, so that includes our low gain and high gain antenna. And then on the bottom, we have our anchor that will drill into the regolith and keep it stable while it deploys MORT. Here is the CAD of MORT. So on MORT itself, it has 2 HAZCAMs. It has LiDAR, a neutron detector, and various atmospheric sensors.
The primary power source for both Julian and MORT will be the multi-mission RTG. This has been used on Perseverance and Curiosity, so there's high reliability. We will also be using secondary batteries that have a silicon anode base, pretty advanced, and have a very high energy density. Julian will have a copper pipe refrigerant coolant system distributed across the main vehicle body to keep our sensors warm. And then on MORT, we will have patch heaters along with aerogel insulation to provide warmth for the sensors on MORT. Low-density communications, such as telemetry and commands, will be done via the Deep Space Network, and then we will have high-volume communication via the Mars Relay Network for actual scientific data uplink.
Rough development budget for Julian is around $120 $20 million versus around $40 million for Mort, as Julian is a larger system and includes expensive components such as the RTG. With margins as well as launch vehicle cost and other elements, our total mission cost will be around $900 million. As we are early in the design process, we wanted to go over some risks and mitigation strategies to make sure that this mission will be successful going forward. Some main ones we've identified here are the cooling pump failure, power system battery degradation, structural failure from a fall, tether communication cable breakage, and LiDAR scanner harness failure. All of these, with the exception of the harness, are medium risk overall because they can be reduced through methods such as power cycling the RTG, changing the communication infrastructure, or proceeding with caution.
Thank you for listening, and we look forward to seeing you at the 2025 Capstone Project Expo.